Hi, and welcome to this problem solving session. This is Ogeze Chiadozie from Special Maths Academy. In this video, we're going to be solving question 33 from 2021 Senior Maths Olympiad first round. The question goes like this. Let GCD of x and y be 1. How many possible values can GCD of x plus y and x squared minus xy plus y squared have? For the sake of those who are not familiar with the term GCD, the GCD or the HCF of two numbers x and y is the highest number that is a factor of both x and y. In solving this question, we're going to make use of the Euclidean algorithm. I'll show that to you. Algorithm. So the Euclidean algorithm is a method of finding the GCD of two numbers. We'll start with an example. So let's say we want to find the GCD of 32 and 12. What we do is that we replace the larger number with the difference between the larger and the smaller number. And so this will be GCD of, since 32 is the bigger number, we'll have 32 minus 12 in place of 32, and 12 stays as it is, which is equal to GCD of 32 minus 2 is 20, and 12 remains as 12. And this is equal to, since 20 is the larger number, 20 will be replaced by 20 minus 12, and 12 still stays the same, which is equal to the GCD of 8 and 12. And this time around, 12 is the larger number, so 8 stays as it is, and we'll have 12 minus 8, which is equal to GCD of 8 and 4. And this is equal to, since 8 is the larger number, GCD of 8 minus 4 and 4, which is equal to GCD of 4 and 4, which is equal to 4. So all you have to do in the Euclidean algorithm is just to keep on subtracting, replacing the larger number with the difference between the larger and the smaller number. So let's say we're taking GCD of 25 and 10. This is going to be the GCD of 25, since 25 is the larger number, 25 minus 10 and 10, which is GCD of 15 and 10. And then this is equal to GCD of, since 15 is larger, 15 minus 10 and 10, which is GCD of 5 and 10. And since 10 is larger here, that will be GCD of 5 and 10 minus 5, which is GCD of 5 and 5, which is equal to 5. And so that's what the Euclidean algorithm is all about. And also, in the Euclidean algorithm, a faster way of going about this is, instead of just replacing the larger number with the difference between the larger and the smaller number, you are going to replace the larger number. You are going to replace the larger number by the difference between the larger one and the largest multiple of the smaller one less than the bigger one. It sounds a bit complex, but we'll just show how that works. So we'll go back to the 32 and 12 example. Let's say we're looking for GCD of 32 and 12, right? This will be equal to the GCD of 32 minus, the largest multiple of 12 less than 32 is 24. That will be 32 minus 24 here instead of just 12 and 12. And that is going to be GCD of 8 and 12. So what we did here is that instead of going through this step and then going to this one, we jumped both steps. And yeah, that's just the main idea of this other way of approaching the Euclidean algorithm. It's just subtracting the largest multiple of the number one, of the smaller number from the bigger one. And then from this point we have GCD of 8 and 12 minus 8, which is GCD of 8 and 4. And then everything just goes on normally from this point onwards. So that's just another way of using the Euclidean algorithm that you should be familiar with. This is going to be GCD of 4 and 4, and we have 4. So it's just the same. It's basically the same thing I'm doing. It's just that you are able to skip more steps and you're able to proceed with the algorithm faster. So we're going to go back to our question now. So the question asks us to find how many possible values can GCD of x plus y and x squared minus xy plus y squared have. We'll go down here. So we're talking about GCD of x plus y and x squared minus xy plus y squared, right? So we're going to be using the Euclidean algorithm here too. So this is equal to the GCD of, it doesn't really matter which one is smaller in the Euclidean algorithm, it works both ways. So we have x squared minus xy plus y squared. Then we can subtract a multiple of x plus y, and a good one to use will be x plus y times x plus y, since it will help us to cancel out the x squared and y squared. So this is equal to the GCD of x plus y and x squared minus xy plus y squared, minus x plus y times x plus y is x squared plus 2xy plus y squared. And so this is equal to the GCD of x plus y, and x squared cancels x squared, y squared cancels y squared, and we have minus xy minus 2xy. So this is equal to GCD of x plus y and minus 3xy. At this point, we're going to do something. We're going to show that the GCD of x plus y and x is 1, and the GCD of x plus y and y is also 1. Or in other words, x plus y and x don't share any common factor, and x plus y and y don't share any common factor. So we'll just bring that out separately. So we're looking for the GCD of x plus y and x, and from the Euclidean algorithm, this is equal to the GCD of x plus y minus x and x, which is equal to the GCD of y and x. And the question told us that the GCD of x and y is 1. So the GCD of y and x is going to be 1. This means that x plus y and x don't have any common factor. We'll do the same thing for x plus y and y. So we have GCD of x plus y and y, and this is equal to the GCD of x plus y minus y and y, which is equal to the GCD of x and y. And the question told us that this is 1. So this means that x plus y does not share any common factor with x, and x plus y does not share any common factor with y, and therefore we can cancel x and y from the right hand side. And so this means that the GCD of this is going to be GCD of x plus y and minus 3. Since we know that x and y don't share any common factor with x plus y, so it doesn't really make any difference whether they are there or they are not. And at this point, we have GCD of x plus y and minus 3. And the only values that this GCD can take are the factors of 3, which are 1 and 3, which means that there are only 2 possible values that GCD of x plus y and x squared minus xy plus y squared can take.